Okay, hi everyone, welcome back. So this is just another data wrangling video. It continues on for the previous two videos where I was demonstrating how to wrangle data, handle data frames using the pandas software library in Python. So if you recall, we'd imported pandas as PD and then created this made-up data frame where we've got four variables. We've got the age of each participant, the name, some sort of ID reference number, and just their date of birth. And I demonstrated how to do various things in the previous videos, such as selecting portions of data, renaming variables, splitting strings, and then combining them to create new variables. And then the last thing I did was show how to filter using multiple criteria, so we can extract objects focused just on certain groups. So a couple of other things to cover in this video, one of which is creating dummy codes for variables. So one hot encode is one way to do this, and it basically represents categorical data with zeros and ones. It's quite common when we have a categorical variable in a data set that we want to create dummy codes for the categories in that data. So what we often do is we take one of the levels of one of the categories as a reference level, and then we code all the others using some sort of dummy code, and then we can compare the difference in scores on each of the groups compared to the reference category. So dummy coding is quite common when we're running some site data analysis. One hot encoding is one way to do that, and what it does is represents categorical data groups with zeros and ones. A one if you're in a certain group, a zero if you're not. So what I'll do in the below example is I'll take the months variable, which has some sort of numerical value from 1 to 12, representing the months of the year: January, February, March, April, etc. And what one hot encoding would do when we create dummies in this year is for a row where the month is January, it would show a row under month 1 and then a 0 for the next 11 columns. We don't actually have all 12 months covered in this data set, but if we did, we'd end up with what's often referred to as a sparse matrix with lots of zeros and a 1 for each row, represent the months of the year split over separate columns. So to do this, what I'm going to do is I'm going to create a new data frame object, dfnew4 in this case, and I'm going to use the pandas getDummies method. So quite useful, something that is commonly used when you're having to create dummy coding for categorical variables. I'm going to take the original df data frame, and what I'm doing is I'm going to create this new variable, which is going to, the new variable is going to have a prefix of mo for month, and then it's going to have an underscore, and then it's going to take the values from the months column and attach that to the name. So we'd have month, as I've got here, mo_1 would be kind of a month 1, January, that type of thing. And remember, the months are not saved as strings as Jan, Feb, March, etc. They're saved as 1, 2, 3. And this last thing after the comma here, drop first equals true. What that means is we're going to use the first value, the lowest value recorded in our months variable as the reference category. So it's going to drop that one. So we've got, I believe in this data frame, we have 6 participants and we have 5 months. Their birthdays fall within 5 months. 2 participants have their birthday in the same month. And what this will do is it will take the month that's the first in the year, the lowest value, take that as a reference category and drop that. So it will return, where we've got six participants, it will return, I believe, 5 or 4 dummy coded variables. So if I run it, hopefully it'll be clearer what that means. So dfnew4, if I run that, what we see here is each participant, and yeah, we've got 4 months. So month, the earliest month for anyone's date of birth in this data set is 02 February. Okay, so if we take month 02, that's going to be the one we drop, and that's going to be our reference category, and then or it'll record whether people's birthday falls within other months compared to that. So for the first one, Rob, his date of birth is in the 9th month, so I get a 0 in all the other months and a 1 in month 9. Cheesy, their date of birth is in February the 2nd. These are all zeros in this row because that was taken as our reference category. The next one is the 11th month, so we get a 0 for the 3rd month, a 0 for the 9th month, 1 on the month 11. Okay, and Sam, we've got March the 3rd month, so he gets a 1 on the month 3, 0 for all the others. And we have a duplicate here, like Ben's birthday falls in the 9th month, so that is a 1 under 9, 0s under other things. So the reason we've not got every month represented here is because there wasn't every month present in this data set. But there you can see you can see how that works there, and if we did some sort of analysis comparing differences in scores between people whose birthdays were in these different months, it would compare each group, each month, to the reference group, which has been dropped in this case, which is February. Okay, so something else that could be quite useful to do would be converting a continuous variable to a categorical variable, and we can do this. So a good way to, from this little made up data set, a good example this would be if we wanted to take ages and then break that into, create a new variable which put their people's ages into categories. Okay, so to do that, what we do is create a new variable, cat age, categorical age, and we're going to use this pandas.cut method. We're going to pass it the age and the value counts for age, and then what we will do is split the data into different bins. It's going to bin people's ages into groups essentially, and if you want n categories, you have to add n+1 boundaries for the bins. So here, I think I will change this. So here we've got, this would split the data for anyone from 0 up to 30 would go into one category. So 0 to 30 is the first bin, and they'd all receive this label as being in their 20s. That's obviously not correct. And then from people 30 to 60, they receive this label saying they're in their 30s. So we could actually change this, and we could add 0 to 10, and then 10 to 20, 20 to 30, then 30 to 60, and we could add some extra labels, and that'd probably be a little bit more meaningful in this case. So let's call the first one child, second one, let's call that, so I'm passing these in as strings, and then we can have 20s and 30s. So if I run this now, it should give us appropriate labels for the people in our data set. So if you can see here, yeah, so anyone whose age is above 30 says they're in the 30s. If they're under 30 but above 20, says they're in their 20s. Up to 20, 10 to 20 says they're a teenager. And anyone whose age is above, anyone who's aged 30 to 60 just says they're in the 30s, which obviously I'm going to change that to 30s plus. That'd probably be a bit more sensible, wouldn't it? Let me run that. And yeah, so anyone who's over 30 gets 30s plus. Okay, so just an example of how we if we had some sort of scale variable and we wanted to create a category, we wanted to bin that into categories that were meaningful in some way, such as what we did here was we split it into age groups and we added labels to those age groups. And you need n plus, if we want 4 groups, we need 5 bins for the cut-off points for the start and finish for all our 4 groups. Okay. Last couple of things. How to use the apply method. So there are lots of different things we can do with the apply method. I'm just going to demonstrate a couple here. So using the apply method, we can apply some function to our variables. And what I'm doing here is I'm taking the name variable from our data frame, and I'm creating, I'm using the apply method on it, and I'm using what's referred to as kind of a lambda function. So it says lambda x colon, and then I've stated x dot upper, and that's in parentheses there. And this is basically, okay, I guess I'll cover these a bit more in depth later on, but the lambda functions, they're like a one-line function that we can make use of in Python, in pandas. And what this is essentially going to do is it's going to take our name variable, create and change it using the apply function. It's going to take all the values in that variable and convert them to uppercase. So if I run that, we can now see everyone's name is capitalized. All the letters of the names are in capital letters, essentially. So a second example of using the apply method and a lambda function. Here what we're going to do is use the apply function to create a variable showing whether the participant's ID number is kind of odd or even. I'm not sure why you'd do this, but maybe you'd want to select certain groups from you and identify whether they'd completed a task or not. And could be anything essentially, or if they fell into one condition or another in your research. So to do this, what I'm doing is I'm creating a completely new variable called even odd, which will be appended to the end of our data set. And I'm taking the ID variable. We're again using the apply method and a lambda function. This time we're saying for our lambda of x, we want it to return 0 if x divided by 2 is equal to 0. So this double equal signs in Python doesn't relate to, when we see an equal sign, it usually relates to assignment. When we see a double equal sign, it's used for mathematical operations such as is exactly equal to. So if we take any value from our ID and divide it by 2, if it comes back as 0, essentially that's telling us that it's even. The participant ID is even. Sorry. This basically means the remainder if we divide it by 2. So the modulus operator here, this percent sign, is basically saying if we take our value, divide it by 2, if the remainder left over is 0, so it's exactly divisible by 2, then it's an even number. Otherwise, else it's a 1. So it's going to return 0s for even numbers, 1s for odd numbers. So in our ID variable, 2 is even, it's going to return 0. 7 is odd, it's going to return a 1. So if we run that, you can see there it's appended this new categorical variable of 0s and 1s, showing whether someone's ID number is an odd or even number. Okay, so that was much longer than I intended this last video to be. I'll stop it here. I've got a few more data wrangling videos to come, and then we'll look at how to run some sort of more common inferential statistical tests and the types of frequentist analyses that we commonly use in classical statistics.